Yes, hello and welcome everyone. I'm Karol Żak. I'm a senior data and applied scientist at Microsoft. I was part of the commercial software engineering group at Microsoft for the last 5 years, uh, and I have some interesting projects in my experience from recent years working with some of our global partners and customers. And today I'd like to share one of these. More specifically, I'm going to be talking about building a video classification system when you can't rely on visual features. Um, a bit more about me. I think most of this was already shared, so let me just skim through it. I have a software engineering background. That's my education, original education. That's where I'm coming from with my experience. I switched to the data science and machine learning path about 5 years ago. And ever since, I've been involved in machine learning projects within Microsoft. We call these kind of projects as code with projects. And basically, the idea is that my team is joining the counterpart on the customer side, and together we're trying to tackle their business problems with ML solutions. And my main areas of expertise and where I had most experience is computer vision, knowledge extraction, obviously deep learning, as it these both together, and MLOps. I have, since I'm coming from software engineering background, MLOps came up naturally in the engagements that I worked on. Just a shameless input. I'm active on GitHub. I have few open source projects. I share some of the work that I do that I can share on my GitHub account on some of the repositories there. So do check that out if you have a chance and you're interested. So let's start from quickly go through the problem definition that we face for this project. So basically, we're working with short 15 to 60 seconds video ads, commercials. There were two different levels of labels that we worked with, 4 top level categories and 30 sub-level categories. On the customer end, they were processing average 1,000 new videos daily, and everything was manually reviewed and assigned these categories or labels. They wanted to introduce automation to speed up the process and obviously save money. And the overall data that they had in the backlog was about 250,000 of videos. And for this engagement, we used only 40K videos as our data set for this feasibility study. And just based on these hints, you clearly can see that the first thought that came up to our mind was, this is a classic video classification problem with visual features and etc. And after a short EDA, we came up with an experimentation plan, which basically consisted of extracting keyframes from these videos, clustering based on on features generated with pre-trained CNN models, then trying some more sophisticated things like fine-tuning the model using transfer learning to our problem, to our data, or training the whole model from scratch on our data, and then eventually maybe moving to more even more sophisticated solutions such as 3D convolutional networks. And basically with our idea, somewhere between points 3 to 5, we were expecting to hit the sweet spot and get some meaningful results and progress with it. And yes, when we started executing this experimentation plan, we obviously started from to extract the keyframes. And for that, we agreed with the customer to save time, to avoid building pipelines from scratch for processing. We will use Azure Video Analyzer for Media, which basically generates and extracts video insights, very rich insights, such as keyframes as well, but it's not limited to only that. And we use that basically to quickly advance. As I said before, it was a feasibility study, so we wanted to iterate quickly and fail fast. So we didn't focus on building, pre-processing pipelines from scratch. So we started with that, quickly extracted the keyframes, went to the clustering exercise, and this basically meant that we took our videos, extracted the keyframes, and then fed these keyframes into a network. We use ResNet 50 or something similar just to experiment with it. And for clustering, we basically cut off the head, the classification head of the model, and extracted feature vectors or so-called embeddings, then applied clustering on these vectors to get some meaningful, hopefully meaningful results. Unfortunately, here we quickly discovered that this approach will not work, as in the clusters that came out didn't make any sense, especially when it compared them to compared some of these clusters to the categories that we had, the labels. There was just almost no connection, no relation between them. But we didn't give up there yet. We thought, okay, maybe it was just pre-trained network, not fine-tuned for our data. So let's try to build a classifier using the same network, but let's fine-tune it using transfer learning, fine-tune it on our data, on our problem. Maybe it will perform better. So we used a similar approach, but this time we didn't cut off the full head. Well, we basically changed the head of the network to recognize our categories, and we trained the model as that. And I think this deserves a meme. Yeah, basically, we tried that. We extracted keyframes. We fine-tuned the network on our data, and it was just not good. The performance, the accuracy that we received was just slightly better than random choice. So that put us in a quite inconvenient position, because we were quite counting to hoping to close this pretty fast. It felt like it's straightforward video classification, visual features, but basically at this point we had to resign from this experimentation plan and back off, go back to the drawing board and rethink this, think what can we do differently. And we did. So basically, we did an extended EDA. We explored the results, and we quickly found out that basically, due to the nature of our data, the videos, these are just commercials. So videos under the same category don't necessarily have the same, don't necessarily have to be visually similar. Moreover, videos from different categories can share similar visual features between them, which just further confuses our networks, our models. And at this point, we made a hypothesis based on the some of the examples that we've seen, that in terms of commercials, the video ads, the useful information is shared in these videos through either displayed text or speech. Luckily, OCR info, things such as OCR info and audio transcripts are available in Azure Video Analyzer for Media Insights that we previously generated for, the keyframes experiment. So with that, we could, we thought that we can quickly experiment on something else, on another approach. Since we have these OCR and audio transcript information, we can think about something else, another approach. And our new plan was basically to take these audio transcripts, so text, fine-tune a pre-trained transformers model on our data, and basically cache in, see what kind of results we can get, and hopefully it will be just right, just satisfactory enough for us to proceed. As for the details of our implementation, as I said, as you've seen before, we tried to iterate quickly and fail fast. So we quickly set up an experiment using Hugging Face transformers. That way, we quickly set up our experiment, implemented everything very fast. We decided to use a Distilbert model, which is basically a smaller, faster, and cheaper, and just slightly worse performing implementation of full BERT model. And it was just perfect for our small experiment here. So we iterated quickly. We achieved a very high scores, high scoring results for both high level and sub level categories. And just some of the early iteration results that we've seen, we achieved over 85 accuracy for top level model, which was simpler, just 4 categories, and over 80% accuracy for the sub level model, which was more categories. And we were very happy with these results. I'd just say further down the line, we improved them even more. But that was ultimately what made this project successful, and the solution that we took forward and expanded it even more. As a bonus, interesting bonus, we built an error analysis report, which was basically taking the most obvious mistakes that our model recognized or mislabeled, right? It was very confident in some of the predictions, while this ground truth for this prediction was something completely different. So we took these high confident results and we generated a report. And when we manually investigated it, we found out that some of these ground truth labels were in fact mislabeled. So the human annotators, which originally added these categories, assigned these categories, added them incorrectly. And we found out these mistakes and we passed these to the customer so he could improve these ground truths for further experiments. Almost the last note I wanted to mention. After this engagement, it was obviously more complex than that. This is just an overview, but we took the code that we built for the customer, we generalized it, stripped it from any customer references and customer data. We also, to be fair, we also simplified it because the actual code, the actual system that we built for the customer was much more complex and used much more insights from the Azure Video Analyzer for Media. But yes, we generalized this code. We added this reusable source code from the project, along with some walkthrough Python notebooks that you can just check, and reuse. And also we added a publicly available data set, which you can play around with. And we took all that, we packaged it and shipped it into a publicly available repository, which you can find under this long link. Right, and as for conclusions, I think there were many learnings, honestly, from this project. But for me, the most interesting part of it was the pivot that we did within this project. We were very confident that this project will be, classic video classification project. We will be using visual features, and eventually we fell with this path, and we were not afraid to step back, rethink this, and pivot away to completely different path and tackle this problem from completely different angle. And I think it's a good thing to take away. So, never be afraid to experiment and try to tackle these problems from completely different angles, applying different ideas. You might just find something interesting there. Another thing is that there's really plenty of ready-to-use tools which can accelerate your experiments, your solution, and get you to some satisfactory results faster than you would get there by building some custom preprocessing pipelines, building something from scratch, implementing something from scratch. So especially for these kind of feasibility studies, quick investigations, explorations, it's very nice to use to have all these tools and use them appropriately. And again, especially in our team, we have this strong principle, strong belief in trying out different things, and most importantly, fail fast instead of heavily investing in a single path, and then building, all this code, all these experiments, and then eventually realizing that all this months of investment was not really worth it. That's why we use these other tools. We experiment, we try out different things, fail fast, prove or disprove some hypothesis, and that way we progress and iterate fast to some successful projects. Right, and with that said, thank you for your attention. I think we have a tad bit more time for some questions and answers, so I'm happy to answer any if there are.
Sure. Yeah, actually, we have a question in the tab. So the question is, well, first of all, great talk, and thank you. Also, the participant, thanks. And well, the question is, did you investigate how important was the on-video text as opposed to the speech transcript?
No, we didn't actually. Well, we honestly, yes, I mentioned OCR info, but actually within this feasibility study, we didn't get to the OCR. We started with transcripts, and that's what we used for all the results that I was sharing. We didn't get, since we got so good results with transcripts, we didn't even get to the OCR. We just like mainly because at some point we passed this project completely to the customer side, and we added this as one of the recommendations for going forward. So that was it, along with other recommendations like incorporating video metadata into the text as well, and fitting into the model too.
Okay, I see. Yeah, it makes sense actually. So yeah, we have a second question, and the question is, what was the approach to predict labels on 2 levels? Did you use some hierarchical classification concepts? Because I remember you mentioned that, yeah, you have some like 2 levels of categories, right?
Yes. So actually, we just built a separate model for each for top level categories and sub level categories. Yeah, the only difference was in the process while scoring or inferencing, running the inferencing. So basically, for top level categories, there was one category which didn't have sub level categories. It was basically a category on its own and without any sub level. So the only difference, so yeah, we trained 2 separate models, and during inferencing, we either went through both of them. If we hit a certain top level category, that was where we ran first, and then if needed, we ran the sub level category model to get the sub level. But like I said, it was just for the 3 of the 4 top level categories. If that makes sense.
I see. So you didn't even try with some hierarchical approach, right?
No, we didn't do that. No.
Okay, we have another question, and the participant is asking, do you think that it was possible to avoid first approach by looking and analyzing data more as a first step?
Yeah, I'm actually glad that this question came up. And yeah, although I think that the whole presentation flow was showing it in that kind of way, the approach that we took was slightly different. As in, yes, during the EDA, we quickly realized that these videos might be hard in terms of visual features because of the reasons that I described in the presentation. But it was just a hypothesis. So basically, we had to run this experiment to confirm this hypothesis that the visual features will not be good for us, right, and for our data.
Yeah, probably watching like 40K of videos or just a subset, it will take a lot of time to just to do that, to validate, like to take some decision. It would be very, very hard probably, right?
Yeah, that's why we took a small sample, we investigated it, and that was one of the assumptions, one of the hypotheses that came up, that visual features might not work, but we have to confirm it anyway. Try it out and see.
Yeah, actually, I wanted to ask, how much time it took to like contradict this first hypothesis that you had, that visual features may be enough or no, because yeah, after that you back off, right?
Mhm.
So I'm curious to how much time it took.
Um, I don't remember the exact number of days, but I think it was just few days, couple of days that again, we were able to, like I said, iterate very quickly because we use all these available tools, all the pre-implemented, pre-trained models. So it was very fast. We were very fast to progress with that.
I see, I see. Okay, I didn't actually know that there is such a group at Microsoft that can, prepare those solutions to the customers and deliver that. I'm wondering, what is the exact way you deliver those to the customers? You deliver this like as a form, like some recipe that they can do it on their own on Azure, or is it something that they can run on prem, or how exactly this works?
Hmm. Yeah, that's a complex question. But in short, well, we basically build a solution. We build a system. What I described here was mostly the feasibility study, which is something like a few weeks exercise or just 2 months exercise that we do prior to the actual project to prove or disprove that this approach can work, and we can actually go into implementation and build an overall system based on this approach. And yeah, the actual engagement is usually like up to 6 months, I would say, and this takes into account everything that needs to be built uh, in order to put this thing into production, basically. So any MLOps scaffoldings, all the pipelines, the infrastructure, whether it's yeah, obviously it's mostly Azure, right? Because that's where we get the monetization right out of it. Yeah, but that's another thing. The work that we do is, it's not build work. We are not a consultant organization where the customer pays for our services. We are, you know, we're not getting paid from the customer in that way, right? Through different channels, I would say. But yeah, we always have in our organization, we always have in mind the production. The solution needs to be ready for production. Whatever we build, it's not just a fairy tale, just some made up story. It has to be proved that it can work in production, and we always have, whatever we do, we have production in the back of our heads.
Okay. Good. I have a next question from the audience. So let me read that. Karol, do I understand correctly? Ultimately, you rely only on this textual approach, or do you also provide visual embeddings as auxiliary variable, even though model is still put more emphasis on text?
A very good question. And yes, the final model that we built, which went further into the process, it was based solely on text classification completely. But as I said, we built this set of recommendations for further experiments. We just didn't have time to build all of it and experiment with all of these ideas. But this actually was one of the recommendations going forward. So basically, use some of the visual features like recognizing some of the objects in the videos, I don't know, bottles, human and stuff like this, cars, anything like that, and then pass it as some sort of side loaded into the model in some way. Yeah, we did it as a recommendation going forward for further experiments.
Okay, okay. I think we have one more question, but I think you have already answered that. So the participant is asking, did you go from notebook to prod yourself / your team, or is it passed to another team?
We did it in cooperation with another team, basically. So there was after the feasibility study, we joined another like a dev crew, set of software engineers, which and they helped us to get this into production. Although they didn't have that much experience in terms of machine learning and MLOps in particular. So our help and our team really helped there to deliver that ultimately. Yeah. So long story short, yes, we took part in that and we helped to put it into production. We didn't just throw the notebooks over the fence. And in fact, we just a small amount of our experiments was done in notebooks. We quickly moved to Azure Machine Learning platform. We ran all the experiments. We set up scripts and ran all the experiments against a AML basically, and tracked those experiments and compared them in that way.
Okay. Yeah, I see. Great. So thank you. Thank you for your presentation. It was really interesting to have you here and to talk with you.